Hello and welcome. My name is Prasad Venkatachar. I'm Product and Solutions Directors from Plabs. In this talk, I will walk you through the importance of the data architecture for building a generative AI applications using AlloyDB and its AI features from Google Cloud. The contents of this presentation includes one is the importance of various factors we need to consider when we are building a data platform and for a generative AI applications. One and the importance of generative AI applications for different enterprise verticals and horizontal functions. I want to introduce the Google AlloyDB Omni solution, and then how it will be beneficial for enterprises to build for business applications such as operational store, business analytics, and generative application such as RAG. And I will discuss through the RAG Retrieval Augmented Generation concepts and how we can use AlloyDB AI features to build the retrieval augmented applications. So when we consider about next data platform consideration for generative AI, so the first four fundamental things we need to keep in mind. One is on the infrastructure. So nowadays, a lot of action happening at the edge before data moves code to the cloud. For example, in retail, not only for capturing the point of sales transactions for the edge, but it is also important for a edge inferencing to, for example, preventing any merchandise theft that's happening in the retail, and also a lot of edge applications being used in the manufacturing for a seamless data capture from all the manufacturing device sensors. And the same thing is for oil and gas. It's seamlessly applicable across different vertical, and it's important to have a seamless data movement across a edge core to the cloud, and connected data platform is extremely important. And when it comes to the database which captures this information, not only these database capabilities should be available for not only for an operate server as an operational store and analytics store, it should be enabled and enhanced to serve for a generative AI applications as well. The third important aspect is these generative applications should get a robust enterprise support, and as well as it should serve for any of the enterprise compliance needs such as HIPAA, GDPR, etc. The fourth is this technology, this data platform also should be open source compatible, or it should be open source compatible and should tap into all the latest innovation happening in the open source ecosystem platform. The next, using generative AI opportunity is applicable across different industry verticals and horizontal functions. In this scenario, I picked a three example from a retail. And here, the generative AI applications is extremely helpful for building a product recommendations for retail industries, where based on the customer details and the purchase history, the retail industries can come out with a product recommendations so that whereby based on the user preference and increase the shopping experience, and as well as boosting the retail sales. In the banking and FSI, the generative AI applications helpful for identifying identifying the risk accurately, more accurately, and detecting and preventing any of the fraudulent activities based on the transactions pattern, thereby saving millions of dollars for the banking industry. In the content and media, where based on the embeddings that is generated for this content information, it will be helpful for categorizing, classifying, and serving this content to the users based on their search history and their user preferences. Across horizontal functions too, generative AI applications is significantly helpful. The customer support is one of the low-hanging fruit where it will be immensely benefit not only for building a rich a chatbot with an excellent question and answering. And it is all the discussions, all the information that is stored as part of the customer discussion can be utilized for building carrying out a customer sentiment analysis, understanding the customer requirements and the problems, and serving this information well in, addressing that customer needs well in advance, improve the customer experience. The marketing, it can be used not only for building the rich content marketing collaterals, but also it can be used for ad targeting, customer segmentation, etc. And HR and finance, this is more about productivity improvement in terms of the document extraction, content extraction. For example, in finance, based on the invoice generated, that document, the billing information can be extracted and automatically billed so that the cash flow can be significantly improved in the finance. The next is on considering both from the data platform requirements and the industry needs. Lenovo, Labs, and Google has collaborated to come out with a Google AlloyDB Omni solution. This solution is a one platform to serve all the transactional business analytics and generative AI needs of the enterprises. The foundation element consists of the infrastructure components here, Lenovo Edge servers and data center servers is being enabled with the Labs data accelerator, and the Google Cloud will serve as the complete thief from edge code to cloud. And then the data platform consists of a AlloyDB Omni, which is a Postgres compatible database from Google that will be available on deployable for both on the edge server and the data center server. And AlloyDB, which runs on the Google Cloud, which is a managed Postgres compatible database available on the Google Cloud. Both Omni, Google AlloyDB Omni and AlloyDB has an excellent built-in capabilities for serving an e-commerce applications with a transactional database store and a built-in columnar engine to deliver a rich real-time business analytics, and as a vector database to enabling the enterprises to build a generative AI applications such as chatbots and some of these applications. Now let's look into how this solution helpful from a transactional real-time analytics and a generative AI applications. So we know that the Postgres is one of the popular databases being used in the industries, right? So we wanted to assess the performance of the AlloyDB solution comparing to the Postgres, and we carried out a HammerDB benchmark, TPCC benchmark to assess its performance. As you see in the chart, the Postgres compared to the baseline PostgreSQL, AlloyDB Omni product provides a 2x performance benefit over the AlloyDB PostgreSQL. And then AlloyDB Omni solution powered with Lenovo and Labs data platform takes that performance benefit to 4x. That means the 500K transactions is increased to 2 million transactions. And this will be significantly helpful for retail enterprises or any of the front-end e-commerce applications to serve more number of web and mobile users so that they will able to take care of more users' requests. And it also be helpful where during the peak seasons, most of the retailers will add more number of, increase number of horizontal scalable, more number of nodes to serve more number of users. So here, this solution will be helpful for very seamlessly scaling or economically scaling the application footprint based on the peak database demands. Second is more from an application user experience, significantly depends upon the database latency. And this database latency can be classified into two segments. One is a average latency, which takes is into the mean time for the mean time taken by the database to complete the database transaction, and the tail latency, which is like, the 99% of the users, which is gets a consistent latency benefit. Latency reduction benefit. So when we carried out this benchmark, we realized that compared to the PostgreSQL baseline, the AlloyDB Omni provides a 60% reduction, and further reduced by AlloyDB Omni with the PLABS acceleration. So there is a totally 85% of latency reduction compared to PostgreSQL, where the latency is reduced from a 24 millisecond all the way up to 6 millisecond. And we also wanted to make sure the 99 latency performance benefits also to be explored. And as you see from the chart, compared to the PostgreSQL, doing at a 50 to 53 millisecond latency for a tail latency is reduced almost up to a 22 millisecond, 24 millisecond latency. That's almost like a 64% latency reduction. So this improves both from the average and tail latency will be reduction is extremely beneficial to provide a rich user experience for e-commerce applications. Then most of these retail enterprises wanted to see what are my top selling products, how is my product promotions are working for a last 1 hour or the last couple of hours, and do I need to take any corrective actions to make sure to increase the sales. So for such kind of a requirements, typically in the regular databases, you have to move the data from a particular, the transactional database into another analytic database. However, to address that need, Google AlloyDB provides a road to columnar store, columnar engine benefits where the given number of row store contents can be seamlessly moved into columnar store, and the AlloyDB recommends what kind of a tables needs to be moved from based on the transaction query, the query pattern, and then populating that data into the columnar engine, how much memory needs to be allocated. When we carried out this, this moving from populating that row into columnar store using a TP-Sage benchmark. Here is the test results been shown. However, Google, when they carried out, they have seen as almost 100x performance benefit moving from a row store to columnar store. However, in our scenario, our benchmarking is much more stringent, much more restricted, where we wanted to have 100 of a scale factor, which translated 200 GB of data set, serving from a 512 GB of a memory. That means entire data set is sitting in the memory. And in this scenario, even that kind of an extreme scenario, moving from a row to columnar store, we have seen in all the 22 queries, which is typically which is more for used in the retail for evaluating the performances, where we've seen around a 4x performance benefit. And the same, some of the queries like query 4 and query 16 has shown almost like 16 to 26x performance benefit. So all these benefits will serve from a out of the box from the with no changes required in the application space at all. Then moving into next is a generative AI. Before getting into generative AI, I wanted to step back and see the typical AI implementation cycle, which includes data preparation, which takes care of identifying the data set, data cleansing, data transformation, and feature engineering, all these activities, and then finding the building and training the model using the appropriate framework, validating the model so that it meets the model, the accuracy requirements, and deploying and monitoring the model to ensure that there is no model drift happens, right? So all these things takes several months of effort. However, with the generative AI model lifecycle, these efforts can be significantly reduced from months into days of effort. Here, it involves four fundamental steps. One is choosing the particular LLM model, whether it would be an open source model or it is a commercial model, and the size of the model, and whether you need a multimodal model. So identifying the type of the model and then customizing it to the enterprise needs, but using some of the techniques like prompt engineering, retrieval augmented generation, and fine tuning. And the rest of the deploying and monitor model is same follows into the AI generative lifecycle. The rest of the slides, I will be discussing more into the retrieval augmented generation. In this case, the retrieval augmented generation is extremely helpful for enterprises to build very informative chatbots by integrating the data that from the enterprises data sources to the power of the LLM and providing a much more context relevant responses to the users. RAG can be used also to provide a similar content based on the text and image and video information. And then the retailers, fintech, and insurance companies can provide a very good personalized recommendations based on the products they sell and the different items, the different SKUs they sell to based on the user preferences. And most of these enterprises have a rich, long, exhaustive documents, and to provide a very concise, summarized information for a particular detail that can be obtained using the RAG as well. Some of the advantages of the RAGs, one is it'll be helpful to reduce the hallucination to a greater extent, thereby the answers that will go obtained or delivered to the users will be free from more contextually relevant and as well as factually correct. And then second is it will provide an up-to-date information for the users. And third, it will be the users able to cite where these responses is coming from, which document it refers to. All this will be significantly helpful. This slide talks about the architecture implementation of AlloyDB. Here, the input data, the different input data sources is chunked into, sliced and diced into various multiple chunks. Contextually aware chunking is important to while implementing the RAG. And then using a good embedding model, this information is converted, the chunking information is converted into the vector format. And using a LangChain or Llama indexes, this can be accomplished. And this data will be stored into the AlloyDB AI vector store. And it also serves as indexing and retrieving. When there is a next query comes in from the user, that information not exist in the LLM. So then LLM looks into this information from the AlloyDB AI vector store, and then that information uh, is passed on to the user's response. That particular chunk of information is passed on to the user's response. This slide goes into the little bit technical details of the how AlloyDB AI can be implemented. AlloyDB AI is a rich collection of AI capabilities from the Google to provide to enable the enterprises to build a rich generative AI applications. So the high-level implementation steps involves one is creating the extensions of using Google ML integrations as well as the PG vector, and then registering the embedding model to the AlloyDB. So thereby enabling the enterprises to create the embeddings within the AlloyDB. No need to switching into a separate Jupyter notebook, calling that particular embedding model. All this can be accomplished within the AlloyDB itself, and storing that vector form data into the AlloyDB. Then once the vector form data, once the data is stored in the vector format, then the next step is used to find the similar items for the search, for the vector search, finding the similar items using a matrix called a distance matrix. Here, there is a 3 or 4 important distance metrics. One is the finding the similar metrics using the L1 distance. It's also called as Manhattan distance. It is the absolute sum of the values of the two vectors. And this L1 vector is extremely scalable, and it is a small values is stored into the AlloyDB. And the second one is the L2 square distance, which is a square root of the sum of the values of the vectors. And this L2 distance is also called as Euclidean distance, measures the distance between the two vectors. But to get a more accurate result, the cosine angle or cosine distance is extremely helpful. Instead of measuring the distance between the two vectors, cosine distance measures the angle between the two vectors. And this is extremely helpful if the input data is highly dimensionally, high dimensionality, high vector space. So this will provide a more accurate results. The next is the indexes. Here, unlike the traditional databases where the indexes, the B-tree index is used for accelerating the search, in this case, it uses the vector indexes, a special form of vector indexes to accelerate the nearest neighbor search. And Postgres uses two variants of it. One is IVF plot, inverted file with a flat compression, and a hierarchical navigable small world HNSW. IVF plot uses a organized in the form of a groups of cluster. When the search query vector comes and it looks for which group of clusters is closer to the search vector, and that particular cluster is identified, then within that cluster, which element of that group is closer to the search vector is identified as the next step. So this IVF plot is helpful for a large data set, and it is extremely scalable. However, the results that come from the IVF plot not necessarily will be will be accurate. So hierarchical navigable HNW is immensely helpful, provide a more accurate result. It uses the state-of-the-art graph algorithms to provide that more accurate results. And it is organized in the form of a multi-layered graph. Each layer is a subset of the previous layer, and the rich higher density goes into the bottommost layer. And however, the construction of the graph will take more time, more memory, and it's complex to maintain. Um, so in order to address that HNW limitation, Google has come out recently with a scan index, which is a scalable nearest neighbor index, which is one of the Google research project now adapted into AlloyDB. And it is organized in the form of a search tune, where in this the index size is much more very smaller compared to HNSW, and since it uses vectors are stored in the form of a contiguous memory, and it uses the tree quantization technique, so that the memory requirements is reduced by almost 3 to 4x, and the index creation is since it takes a less index space, I mean less space, so the index creation is much more faster, almost like a 8 to 8x faster. And since it is used, reduces the search space using the search tree, and lower number of branches needs to be searched for a given search vector, and thereby increasing the search speed by order of 4x. The vector indexes, vector search acceleration is increased by almost like 4x. Now, putting all together, if you're building for enterprises to build a rich generative AI application, especially in the RAG application, AlloyDB Omni enables for the users to use any of the LLM foundation models. It is a Google's Vertex AI or a open source Gemma or OpenAI models, and orchestration framework to support both LangChain and Llama Index. AlloyDB has the AI enhancements include the vector search. We discussed about PG vector and the scan index. And the second is it enables a natural language where the users can use a natural language to generate a rich SQL code. And also it provides a intent clarification to make sure the user's intent is rewritten, and the prompt is rewritten to ensure that particular data is provided. And it also provides a parameter secure views to provide a rich set of data security, so that only that particular user is able to provide obtain their information for that specific user. And it also provides a model endpoint management and embeddings generation. And it also enables for the users to create a Vertex AI inferencing. To sum it up, everything, the data platform should able to serve the business needs of an operational databases as well as an analytics database, business analytics, enable business analytics, as well as to support a fast evolving generative AI application as a vector database. And these infrastructure should be seamlessly able to connect from a edge core to cloud. And this way it will be enabling a connected infrastructure and a connected data platform. So with that said, thank you for your time, and please take a moment to rate my session.